Okay, in the last part, we have discussed how to view the design pressure. This is a mat footing. Now you can see, if you want to see the reactive forces, just go here, put soil pressure, apply, close. So here you can see that the maximum pressure is 3.6 kilopascal, and the minimum pressure is around 1.6. So I could not find any kind of uplifting, because I could see that almost all the parts are above. All the parts are above. All the parts are above 1 point. I could not see 1.6 or 1.2, 0.8. So the values are between minus 3.6 and 0. Okay, if you want to check uplift, yes, of course you can check, but before that I want to talk about some other things like punching shear. Now if you run the design and design combination, all these design combinations are there, okay, and display show punching shear design. Okay, if you click here, you can find out these values. So under each column the punching shear value is given, like under this column the punching shear value is 0.4153. The punching shear values near the corner columns are expected to be the maximum, which is the same in our model, and for the interior column the punching shear values are less. And this is a shear wall where you can see that there are no punching shear, and it is also not checked, you can say. Now next is the same thing about the design strips. When you are designing the mat foundation, there are two important things. Number one, the pressure should be less than the available bearing capacity. In our case, it is not only less than, but it is very less than the bearing capacity, which is around 200 kilopascal, and our available capacity is too high. So it means that for this kind of building the mat footing is not required, but we have provided. Anyhow, let's see how much was the depth of mat 600. The depth of mat footing is 600. Again, the depth of footing is like punching shear is 0.561. The maximum value. You can reduce the depth of slab. If you go here and if you go to draw, define slab properties, mat, modify. Okay, now I change the depth of footing like 450. Okay, and then I again run analysis and design. Okay, so this is a deformed shape. If you click on 3D view, you can see the deformed shape like this. The maximum uplift is at the center. It is not uplift anyhow, but it is a deformed shape. And now if we go to display punching shear, show punching shear design, yes, now you can see the punching shear values are increased from 0.56, but still they are in the same. What is this? This is actually VU over 5EVC. It means that the required factor shear divided by the shear capacity, which is, it means if it is less than 1, your capacity is more. So from this we can see that we can further reduce the depth of mat footing. Maybe I'm not sure it will work for 300 mm or not, but you can check. Okay, next is you have your bearing capacity is okay, your punching shear is okay, then you can go for the detailing. We have already provided the design strips. If you don't know how to assign these design strips, please watch my second part of these tutorials. In that part I have explained in detail how to do detailing and all these stuff. Okay, so if you just run detailing, you can see the detailing. I have discussed the detailing in detail in my second part of the video, so I'm not going to repeat all these things. There is no beam in fact, but it is taking the shear wall effects. That's why it is giving the shear wall as the beam designation. Anyhow, next, so it means that our footing is almost designed. If you want to see the design reinforcement display, okay, go here, display, slab design, default 2D, okay, and this is default 3D. These are your design strips. So you can move your cursor and you can find the design reinforcement in both directions. Okay, these are the design strips. Okay, now actually this is what I explained you how to design the mat footing in the third and fourth part of these tutorials. Now in this part I explained you if you want to design a strip or isolated footing, how you can do it. Okay, but before that I just want to tell you how you can create the report. I have already explained you. If you want to export some drawing, you can go to export drawing. You can click the current sheet or select sheets. For example, if you select slab rebar plan top bars and slab rebar plan bottom bars, I make it okay, and this is the folder. And then if you click on start export, it is started and done. Okay, let me see if these files are there. Done, save. If I click on the file type, slab sections, because there are many drawings here. Okay, this is the slab sections. Let me see. I think it is not the license. Okay, anyhow the drawings are generated. You can see the details of these drawings over here. These are also the DXF files, first floor beam and mat footing design slab rebar plan. Okay, it is not the registered product. Anyhow, you have the registered product, but what I want to tell you that these two drawings are generated, the top and bottom rebar plans. Okay, these two bars, these two. Next, so it means you can export, you can edit. I have explained detailing in detail in the second part of my safe tutorial. You can find on the YouTube or internet. Okay, next, if you want for the same building, if you want to design isolated footing or combined footing, now I explain you how you can do it. Okay, again we go to import safe.f2k file. Yes, and mat footing design.f2k. okay, I export it, open. So this is a plan, this is the plan, and these green lines are basically the locations where our columns are located, under which we have to provide it the mat footing. We have to provide the isolated footing. So let's see in 3D, and if you want to see the forces, dead load above, live load above, live load above, point loads, show loading values. Okay, so it means your reactions are over here. Next, okay, if you have to design the isolated footing, you can, the one way is you can select the highest of these all these values, and you can provide that value on in the mat. For example, you can just design one isolated footing and provide it everywhere. This is the one choice. The other choice is that you provide the footing under every column, and then we see either the isolated footing is working or not, or we have to go to the combined footing. So the sequence for the footing selection is first isolated, then combine, and then strip, and from strip or continuous footing, and then we go to the mat footing. And if mat footing is failing in punching shear, we can provide beams or we can increase the thickness. And if with mat footing our design pressures are not achieved, then the next or the last step is the pile footing. So with pile we can increase the length of pile and we can achieve the required bearing capacity of the soil. Okay, now we have to design the isolated footing. So how we can do it? If you just click here and see the loads, this is the load size. It means this is the size of column. These are the dead load, surface finish, wall load, and earthquake, live load, all above. All loads are above. Because at the footing level there is no dead load, live load, because it is just the support. We have considered as a support, and there is no load of this support in the SAP. Okay, so now I go for refine slab, add new property. I make a mat footing. Like if you want to add a material, you can add a material. Let me see what are these material properties. Modify and show. I can modify this material like 20. If I double click here, I can calculate 4700 under root 20. If I calculate and make it okay, maybe I prefer to use 0.15 and say it 20. Okay, and then property name isolated footing. I put the footing thickness like 300. It is footing thick plate. Okay. So now I have to draw it. Define. And if I want to draw it, how I can draw? Quick draw slab and areas. Okay, footing. Okay. Draw object using points or lines. Okay, if I select on the lines, there is one more option in which I can give the size of footing. If I give here the points, if I go here and not available, quick draw areas around point, quick draw slab areas. If we go to draw and draw rectangular slab areas, quick draw slab areas, and draw beam lines, draw column lines. Okay, draw rectangular slab areas. Okay, you can draw the area in this way. For example, around this column you can provide the required size like 1.8, 1.8, okay, 1.5 and 1.5. Okay, this is just the one example. But if you want to draw later on, you can edit this area. So you just click here, right click, and you can go to geometry, and all these points you can. It is not working. I have to click on joint. Yes, click on joint and then right click, geometry, and now I should edit. Anyhow, I try by the other way. Draw quick. No, there is one I'm not able to understand why it is not visible. I mean, I have to give the size of footing and the slab. Okay, property. Okay, isolated F, and then it is not here. I don't know why it is not coming, but these points should be here. Anyhow, we can draw the area by several ways, by even by the line. For example, if you want to draw, you can give a plan offset like 1 meter, the units are, you have to make sure what units are there. If it is, you have 1 meter. Okay, so if you click from here to here, 1 meter over there, and if you click from here to here, 1 meter on this side, and if you click from here to here, 1 meter on the other side, sorry. Like this, and then you can draw the area. You can just drag your point like this. So there are several ways by which you can draw. Delete. In addition to it, there is one special module. If you go to the new model, but I have to undo the model. Just 1 minute.